Hello, my name is Tristan McConney. I'm an undergraduate researcher for the Musculoskeletal Control and Dynamics Lab at Stevens Institute of Technology. Today, I'll be presenting my research titled A Method for Computing Latency of an Interactive Biofeedback Sonification System. Biofeedback sonification systems utilize sonification or the display of data as nonverbal sound. It is an emerging practice in balanced rehabilitation. Sound variables are parameterized user actions, which then are relayed back to the user for understanding. The latency between event and audio for interactive systems of this nature needs to be relatively small in order to ensure timely reporting of data back to the user. The purpose of this research was to create a latency test method to obtain the latency of a motion capture-based sonification system in order to determine if the latency was timely enough in reporting to the user. Our current sonification is as follows. The user is captured using the OptiTrack motion capture system, which then sends the data to the Motive motion capture software. Then that data is sent to MATLAB for computing and analysis. Then the data is sent to MaxMSP for parameterization, which is then sent to the user as audio. The latency test utilizes the same system, but introduces a threshold alert and an auto recording element. A threshold alert, MATLAB and MaxMSP code ran simultaneously as the sonification system. But normal sound generation was muted in Max in order to only hear the threshold alert. All the full body motion capture calculations were retained, as it was important to calculate the latency when sonification was computing and processing full body motion capture in addition to the latency code to find the worst case scenario of the latency. The threshold code assigned a single marker for the motion captures to be tracked as it moved above and below an assigned threshold. When lowered below the threshold, a sonified alert played. When raised above the threshold, no sound played. The audio was recorded in utilizing motion capture software, an audio interface, and a microphone. The tracking data and audio were then exported from Motive to MATLAB, where calculations were done post-processing to find the delta between the threshold passed and the audio heard. These were then graphed to give a visual representation of the data. The audio recordings having significant envelopes allowed for multiple latencies to be calculated within one trial. First, the frames of the motion capture data were converted to the same frame rate as the audio. Next, comparing the audio frames in MATLAB, the first audio frame was found finding the first audio signal with that envelope that was greater than half of the envelope's max audio signal. The delta between the first audio frame and the frame of the passing below threshold was calculated and converted into seconds, giving us a latency of that envelope. Here, the green line represents the time down from the motion capture. The red line represents the time up from the motion capture. The circle represents the calculated magnitude of the start sound, and the black line represents the time down with the delay. With this method, 12 trials were run with 20-second intervals, but only 8 trials were accepted. Each trial gave about 4 to 5 latencies, and the latencies were averaged to find the average latency of the entire system, with the system latency being 0.09824 seconds. That gave it, the latency was about 10.179 hertz. Looking at the latency of MATLAB and motion capture software, MATLAB made up about 50% of the latency of the system with an average processing latency of 0.04537 seconds. Making the code run faster would decrease this latency and in turn optimize it for real-time sonification. The latency itself could be improved. The latency system itself can be improved by making it calculate in real time during the sonification trial. Thank you so much to the Carnegie Mellon Forum on Biomedical Engineering and my team, Mitchell Tillman and Dr. Antonia Zafariu. If you have any questions, feel free to ask. Thank you.